Have you ever wondered why you see lightning before you hear thunder? A common occurrence in our world, the spectacle of thunder and lightning has ignited curiosity and wonder for ages. It's a phenomenon that's as breathtaking as it is terrifying, yet it's often taken for granted. From the ancient Greeks attributing the spectacle to the wrath of Zeus, to the modern understanding of it as a natural electrical discharge, the enigma of thunder and lightning has been a subject of fascination. But what exactly causes this brilliant display of nature's power? Why do we see the flash of lightning before we hear the thunder's rumble? These are questions that have puzzled many for centuries, and today we aim to shed some light on this intriguing subject. So buckle up as we take a journey into the heart of the storm. Today we will unravel the mysteries of thunder and lightning. To understand why we see lightning before we hear thunder, we first need to understand how lightning is formed. Let's start with a bit of atmospheric scene setting, shall we? Picture a stormy sky. Billowing clouds tower above, filled with swirling winds and fluctuating temperatures. These conditions cause the water droplets and ice particles within the cloud to constantly collide with each other, creating an electric charge. The lighter, positively charged particles tend to rise to the top of the cloud, while the heavier, negatively charged particles sink to the bottom. This separation of charges sets the stage for a natural spectacle. A lightning strike. But wait, there's more. The Earth's surface has a positive charge, which increases as the negatively charged bottom of the cloud draws nearer. This sets up a perfect storm, quite literally, for an electric discharge, but it doesn't happen all at once. The negative charges at the bottom of the cloud start to reach out with what we call stepped leaders. These are invisible to the naked eye, but they're probing, searching for a path to the positively charged Earth. Here's a clue: it has to do with the speed of light and the speed of sound. Now let's delve into these fascinating concepts. First, the speed of light. It's the fastest speed that we know of in the universe, traveling at a mind-boggling speed of approximately 186,000 miles per second. That's fast enough to go around the Earth 7.5 times in a single second. When a bolt of lightning flashes, it sends out a shower of light particles or photons in all directions, and these photons race towards your eyes at this incredible speed. Now let's compare that to the speed of sound. Sound travels much slower, around 760 miles per hour, or about 1/5 of a mile per second. The thunderous boom that follows a lightning flash is essentially a sound wave. This wave is created by the rapid heating and cooling of air around the lightning bolt, causing the air to expand and contract quickly, sending out a shock wave that we perceive as sound. So why do we see the lightning before we hear the thunder? It's all down to their respective speeds. When a lightning bolt flashes, the light and sound start their journey at the same time. But the light, traveling at its incredible speed, reaches us almost instantly. The sound, however, takes much longer to reach us because it's traveling at a much slower pace. For instance, if a lightning bolt strikes a mile away, the light will reach you in about 5 microseconds. That's 5 millionths of a second. The thunder, on the other hand, will take about 5 seconds to reach you. That's a difference of nearly 1 million times. So the next time you see a flash of lightning followed by the rumble of thunder, remember, the delay isn't because they happen at different times. Rather, it's a fantastic display of the fundamental laws of physics at work. So, lightning and thunder occur simultaneously, but we receive the light faster due to its speed. But why does thunder make such a loud, terrifying sound? This question has been asked by countless curious minds over the ages. The answer lies in the dynamics of air and energy surrounding a lightning bolt. Picture this. When lightning strikes, it superheats the air around it to temperatures around 20,000 degrees Celsius, or roughly 3 times hotter than the surface of the sun. This rapid heating causes the air to expand explosively, creating a shock wave that travels outwards from the lightning bolt. This shock wave is what we perceive as the initial sharp crack of thunder, but the sound doesn't end there. The superheated air swiftly cools down, causing it to contract sharply. This rapid contraction creates a secondary shock wave, which follows closely on the heels of the first. This secondary shock wave is perceived as the rumbling echo that characterizes the sound of thunder. However, the sound of thunder isn't just a simple crack followed by a rumble. The sound changes depending on your distance from the lightning bolt. When you're close to the bolt, the thunder sounds like a sharp crack because the shockwave reaches your ears almost instantly. But as you move further away, the sound takes longer to reach you, and the distinct crack and rumble start to blur together into a continuous roll of thunder. The shape of the lightning bolt also affects the sound of thunder. A straight bolt results in a short, sharp crack, while a forked bolt creates a longer, rolling rumble. This is because the sound from different parts of the forked bolt reaches your ears at different times, creating a series of sounds that merge into a continuous rumble. In essence, the terrifying sound of thunder is a symphony of shock waves created by the rapid heating and cooling of air around a lightning bolt. Every thunderstorm is a live performance, with the lightning as the conductor and the air as the orchestra. So, the terrifying sound of thunder is simply the result of air being quickly heated and cooled by the lightning bolt. Now that we understand the basics, here are some lesser-known facts about lightning and thunder. Firstly, the temperature of a lightning bolt might astound you. It can reach up to 50,000 degrees Fahrenheit. That's hotter than the surface of the sun, which sits at a comparatively cool 10,000 degrees Fahrenheit. Imagine the kind of suntan you'd get from that. Next, let's talk about the longest recorded lightning bolt. In 2007, a bolt of lightning over Oklahoma in the United States stretched nearly 200 miles in length. That's roughly the distance from London to Manchester. So next time you're thinking of a road trip, just imagine a single lightning bolt covering the entire journey. Ever wondered why thunder can sound like a sharp crack or a long rumble? It all comes down to the distance between you and the lightning. When a bolt is close, the sound waves reach you almost simultaneously, giving a sharp, cracking sound. However, if the lightning is far away, the sound waves arrive at different times, creating a longer, rumbling effect. It's like nature's own surround sound system. Also, did you know that lightning isn't just a terrestrial phenomenon? Oh no, it's also been observed on other planets in our solar system, including Jupiter and Saturn. Those celestial light shows must be quite the spectacle. Lastly, have you ever heard of positive lightning? It's a type of lightning that originates from the positively charged top of a thundercloud. It's far less common and can be up to 10 times more powerful than regular or negative lightning. It's also responsible for many of the lightning-related wildfires we see. These fascinating facts add another layer of intrigue to the already captivating phenomenon of thunder and lightning. So there you have it. We've embarked on a fascinating journey unraveling the enigma of thunder and lightning. We've discovered how a lightning bolt, this electric marvel, is born from the turbulent womb of a storm cloud. It's a dance of positive and negative charges, culminating in a brilliant flash that lights up the sky. But why do we see this spectacle before we hear it? The simple answer lies in the speed of light and sound. Light, the speedster, races to our eyes at an astonishing 299,792,458 meters per second, leaving sound, the tortoise, trailing at a mere 343 meters per second. And so, the light of the lightning bolt reaches us before the sound of its thunderous applause. Next time a storm rolls in, you can impress your friends with your knowledge about the spectacle of lightning and the rumble of thunder.